LR4-2 is a continuation of LR4-1, so we're going to do some more practice on CPCTC proofs. So remember, CPCTC stands for corresponding parts of congruent triangles are congruent. And you can write CPCTC, you can write this whole sentence, or you can say, if triangles congruent, then parts are congruent. So any of those three statements will work. And we're going to start the way we had been starting in LR3 by saying these three parts are congruent, these two triangles are congruent, and then this part is congruent to that part by any of the reasons we stated on this slide. So we're going to do some practice with this. And then you will continue practicing on your own through class kick. So we're given GI as parallel to JI. Even if I'm not sure how I'm going to use it yet, I'm going to write out everything I'm given. And anytime I see parallel lines, I'm looking for alternate interior angles or corresponding angles. So these two lines are my parallel lines. This is my transversal. And sure enough, I have corresponding angles, angle 1 and angle 2. So I can now say that because those were parallel, angle 1 is congruent to angle 2, and those are corresponding angles, so I'll say corresponding angles are congruent. I'm also then told that I is the midpoint of HK. And that was written out for me. So it is given. Because I is the midpoint, I can prove that HI and IK are the same. And my reason here can be one of two things. I can put definition of midpoint, or I can copy exactly what I wrote in step 3 and have that be my reason. And notice, pals, I had to have I as a midpoint before I could be using it as a reason. Okay, you have to use it as a statement before it can be a reason. Similarly, I have to have parallel lines before I can have corresponding angles or alternate interior angles. And then lastly, I was given GH is congruent to JI. Notice they're parallel and they're congruent. Those two are not the same thing. Parallel does not mean they're congruent, so they have to be separate steps. And just because I know that they're parallel doesn't automatically mean they're congruent, and vice versa. I have three congruent parts now, right? I have a part here, here, and here. So my next step is to say this triangle is congruent to that triangle. So I'm going to say triangle GHI is congruent to triangle JIK. And the shortcut I used was side, angle, side, because the angle that I know is between the two sides. My final step then will be to say that this part's congruent to that part. I'm going to look at, I'm asked to prove G is congruent to J. So those two angles, which in my picture should match up, and in how I named them, they're both in the same spot. They're both first in this case. So I can say angle G is congruent to angle J because corresponding parts of congruent triangles are congruent. And my proof is done as soon as I've proven what I was asked to prove. Right, on this next one, all I'm told is ABCD is a rhombus. So I'm going to draw a rhombus. And remember, the definition of a rhombus is that it's a parallelogram with all sides congruent. I'm asked to prove that the diagonals bisect the angles. So I'm going to draw a diagonal in. If that's a bisector, then angle 1 and angle 2 have to be congruent. Okay, so we're going to try to prove that they're congruent by CPCTC. I can get AC congruent to itself. because of the reflexive property. I can get all of my sides congruent, and the pairs that I care about are AB and AD and BC and DC, so that my triangle is folding in. I can use side, side, side then to prove my triangle is congruent. Then I can use CPCTC to prove angle 1 congruent to angle 2. And then because those angles are congruent, AC has to be a bisector. So I kind of reasoned through that one backwards, and now we're going to work forwards to write our proof. So I'm starting with the only thing I was given. And all I was given is ABCD as a rhombus. Even if you're not sure how you're going to use it, write out everything you're given, because you're never going to lose points for giving me more than you needed to. So even if you're given it and you didn't need it, write it out anyways. Why not? Then because ABCD was a rhombus, we were able to say AB is congruent to AD. And my reason is going to be definition of a rhombus, or all sides of a rhombus are congruent. We also said that BC was congruent to CD for the exact same reason. And again, you can copy and paste, or you can do your little tick marks. Look like a grown-up. That just means ditto what I wrote above. And then the third side we said was that AC was congruent to itself. Remember, when something equals itself exactly, that is the reflexive property. And then we can say triangle ABC is congruent to triangle ADC. The shortcut we're using is side, side, side. We were able to prove all of the sides congruent. We've proved 3 congruent sides. We've proven 2 triangles congruent. So now we can say, hey, angle 1 is going to be congruent to angle 2 because corresponding parts of congruent triangles are congruent. But we're not done yet because we were not asked to prove that the angles were congruent. We were asked to prove the diagonals bisect the angle. So now I can say AC bisects the rhombus's angles because I can say angle 1 is congruent to angle 2, or definition of angle bisector. All right, on this next one, we're asked to prove LM is parallel to NO. If they were parallel, then I could prove angle L congruent to angle O, because those would be alternate interior angles. So that will be what I try to prove with CPCTC. Without using those angles, I'm going to figure out what else I can use to prove the triangle's congruent. And I'm told P is the midpoint of LO and of MN, and notice those are 2 different things. So just because it's the midpoint of one doesn't automatically mean it's the midpoint of the other. And then I also have some vertical angles right here. So I can use side angle side to prove the angles are, or the triangles are congruent. Then CPCTC to prove L is congruent to O. And then because my alternate interior angles are congruent, my sides must be parallel. So I'm going to jump backwards. I'm actually going to start with my vertical angles because I'm already writing in orange. I'm going to say angle 1 is congruent to angle 2 because vertical angles are congruent. And if you wanted this step to come later, you could. And then I'm going to write out my given stuff. And I was given P is midpoint of LO and MN. I have to have that before I can use it as a reason. Now that I've said P is the midpoint of those two line segments, I can go ahead and say LP is congruent to PO because either P is midpoint or definition of midpoint. And I can say MP is congruent to PN for the same reasoning. I have my three congruent parts. I can go ahead and say my triangles are congruent. So I can say triangle LPM is congruent to triangle O matches up with L, P matches up with P, M matches up with N. And we used two sides and the angle between them, so that is side, angle, side. And we said before our strategy was to get angle L congruent to angle O by CPCTC. Once those are congruent, I can jump in and say LM is parallel to NO because if alternate interior angles are congruent, then lines are parallel. Once I've proven what I was asked to prove over here, my proof is totally done. I am good to go.